So we'll continue here. So in the last few sessions, we talked about different things. Like we talked about topic, partition, replication, a bit on the producers. We talked about brokers. We talked about leader copy or leader broker and follower copy or follower broker. We also talked about controller broker. Most of the Kafka architecture we discussed, and most of the producer side we discussed. Now we'll discuss on the consumer side, and we also talked about the different. My voice is not audible.
It is good, Pramod.
Okay. Sandeep, I see that your audio is not connected. I mean, well, I should message him. Yeah. Now today we'll see the consumer side a bit. So before we look into the consumer side, so there is something called as offset. Now what is offset here? Now we know that the producer sends a message. The producer sends a message here. We know that how the message looks like. The message, again I said that it is in the form of key, comma, value. This is how the message looks like, key and value. Now as soon as that message is received by the broker adds a offset here. I mean a number starting from 0, adds a number. That number is called as offset. So it will be something like this. So you have your message. Now it will be 0, key, value. Key 1, some key value. The next message, this is our message 1. Message 2, 1, key, value. This is our message 2. Similarly 2, key and value. This is our message 3. So that's how the offset is added. For every partition, the offset is added by the broker. If we have sensor 1, let's say we have sensor 1, obviously the producer will also be sending few messages here to this broker. So this will also add a offset. Again the offset will start from 0 and it will monotonically increase by 1, key value. This is a message 1, key value. 2, key value. So the broker will add a number and that number is called as a offset. So from the producer we only get the data as key value. This is your message. As soon as it reaches the broker, broker adds a number, and your actual message contains all these three. It also contains it contains the offset, it contains the key, it contains the value. That's all. That's the whole thing is contained as a message. That's what we say as a message. So I hope the offset, how offset is clear created. I hope it is clear. Now the question arises: what is the use of offset? Any guess what is the use of offset here? Can anybody tell what is the use of the offset here? Right, it is kind of, we want to track the messages. That's correct. Track or locate the messages, which messages we want to read. So it is used for that purpose. So if we have a consumer now, consumer or the replica broker. Let's say this is our, so we have a data in this fashion. So we have our consumer. Let's say it is a Spark consumer. We will explain other things as well. Just few things you have to assume now. Let's say we have a Spark application, Spark streaming. So we have consumer one. Let's assume that we have consumer two, consumer three here, or just say we have just consumer one and consumer two. The way the consumer sends the request here is, consumer will send a request to this broker, because this is a, let's say this is our leader. Sensor hyphen 0 is the leader copy. This is our follower copy. Sorry, this is, I should have written as 1. My mistake. It should be 1 here. That's the reason it is sending. Otherwise, it will never send it to the follower copy. This is one more partition. Hence the producer is sending the data to the leader copy. These are all follower. And we know that the communication only happens to the leader copy, and let's say we are having two partitions. So consumer 1 is connecting to broker 1, and usually consumer 2 will be connecting to the broker 4. So this is a leader. Now how it will start consuming the messages. This consumer will send the request that I want data from sensor topic, I want partition from 0, and I want offset from 0. In a similar fashion, the request, this sends is, this consumer to the request that it sends is, it says I want data from sensor topic, I want data from the partition 1, and I want the data from offset 0. That's what the first request will go from the Spark streaming application. Now it has said that I want the messages from offset 0. Now how many messages the broker will send to the consumer? It did not say that I want it from this offset to this offset. It has only said send the from offset, not the to offset. So how many messages the broker will send the consumer? So again, that depends on min fetch bytes. So we saw something like this, right? So on the consumer side, so we have something called as fetch min bytes. Fetch min bytes. So how many bytes minimum the broker might should have so that it can send it to the consumer. So on the consumer side, there will be min fetch bytes. So it will send that request to the broker. Broker will see that min fetch bytes is some bytes. As soon as that bytes is received by the, or it is as soon as those much bytes is available in the broker, or as soon as those many bytes it receives from the producer, those bytes will be sent to the consumer. That's the minimum. It can send more than that also. Minimum that much messages, that much bytes has to be there. Let's say if it is asking for min fetch bytes is equal to 100 bytes. So broker should minimum send 100 bytes, but it can send some 200 bytes. If it has some 500 bytes, it can send. If it has some uh, 10k bytes, 20k bytes, 50k bytes also, it can send. It's not necessary that it has to exactly send 100 bytes, but minimum it has to send 100 bytes. So let's say the broker sent, let's say the broker sent 10k bytes, 10 kilobytes. So this 10 kilobytes could be some five messages. It could be some five messages. It may anything, because your message size may vary. 10k bytes could be five messages, meaning the broker has sent five messages. Five messages means zeroth offset, first offset, second offset, third offset, and up to and fourth offset message. So once it receives five messages, the consumer will send the next request saying I want data from sensor topic, zeroth partition, and already it has got the fourth offset message. It will say that I want the message from fifth offset. Again, that request will go from fifth offset. It will start sending messages based on min fetch bytes. So let's say this time it got 50k, which may correspond to some 20 messages. First time it got 10k bytes. A broker sent 10k bytes. Second time it sent 50k bytes, which may correspond to 20 messages. Meaning, from fifth offset, it has read up to 24th offset. So the next request that it will send is sensor 0, comma 25. That will be your next offset. So that's how the messages are consumed. That's how the message, and that's where the offset comes into picture here. And the same things comes here also. If it has received some six messages, if it has received some very first time it received some six messages, here the next request that will go is sensor topic partition 1 from offset 6. Next time it received some 10 messages, so totally 16 messages means up to 15 offset. So sensor 1, give me the messages from 16th offset. So I hope the offset was clear here. What is the use of offset? Offset is always used to fetch the next message. Offset is always used to fetch the next message from the Kafka broker. So I hope it was clear. I assume here it was clear. Okay. Now, now, now the replications are also done in the same fashion. I said that the consumer, the follower brokers acts just like internal consumers. So they will also send the same request. They will say that I want message from sensor topic, partition 0 and from offset 0. And it will send some messages. And that messages will be returned to the sensor. I mean it to the appended to the log file. Similarly, if let's say similarly if there is one more broker which has sensor 1, these will send the request to the broker. So it will also send sensor partition 0 from offset 0, and so on. It will be keep on sending the request, and the leader broker will be sending the messages, and the follower broker will append those messages to its copy. Similarly, if we have broker 5 will be sending a request to broker 4 for sensor topic 1. So it will say sensor partition is 1 from offset 0, from offset 0. So that's how the replication works. So you can clearly see that it acts just like a consumer. So it is just an internal consumer, and that's how the data is replicated. So I hope the use case of the offset was clear. It's always to read the next element, sorry, next messages from the topic. Now in Spark, actually what happens, Spark streaming. So let's say this is our broker 1, this is our broker 2, and this is our broker 3. So broker 1 is responsible for sensor topic 0th partition. Broker 2 is responsible for sensor topic partition 1, sensor topic partition. Then the replication is also there, but let's not worry about the replication here. And let's say this is our Kafka cluster. And here we have our Spark cluster. So when we want to consume data from Kafka using a Spark streaming, so it will be usually there will be a one-to-one mapping from the partition in the Kafka to the partition in the Spark. Meaning here we have one task, here we have task 2, here we have task 3. So this task will be acting as a consumer task. This is a consumer task. These are consumer tasks. So the consumer task will be reading the data from the brokers here. One task for one partition, and hence it will get one partition here. So I will just write it as partition 0, partition 1, and partition 2. So whatever data it receives from the Kafka, from each broker it is treated as one partition, and this is our RDB. That's how the Spark streaming works actually. So hence there will be a one-to-one uh, mapping to the partition in the Kafka to the partition in the Spark here. Now sometimes what happens, if I generalize this, not with just respect to Spark, let's say we have partition 0, partition 1, and I mean to say we have sensor hyphen 0, we have sensor hyphen 1, and we have a sensor hyphen 2. So we have three partitions in our Kafka. So when if at all we have three consumers here, when we say consumer, it is internally a thread. When I say consumer, it is just a thread inside the application. So if I have an application here, application 1, which is consuming the data from Kafka. So let's say there are three threads: thread 1, thread 2, and thread 3. It could be a Spark application or any other application as well. So thread 1, this is a consumer and consumer. Thread 1 will be consumer from sensor topic 0. Thread 2 will be consuming from sensor topic 1. Thread 3 will be consuming from sensor topic 2. Now here what happens is, internally one of the consumer is treated as a coordinator consumer. Let's say T1 consumer is a coordinator consumer. Thread 1 consumer, which consumes the messages from sensor topic 0, zeroth partition, it is treated as a coordinator consumer. Now what is the job or the responsibility of the coordinator consumer? Now coordinator consumer will maintain a list of all the consumers. It will check which all consumers are up and running. You can just compare it like coordinator, controller, broker. You can just think coordinator consumer just like controller broker. It will just check the which all consumers are up and running, and then it will assign a particular partition to a particular consumer. It will maintain list of consumers, assign partitions to consumers. That's the responsibility of the coordinator consumer. Again again revoke partitions. Stop saying revoke. So these are the responsibilities: maintain a list of consumer, assign partitions to the consumers, trigger rebalancing, rebalancing whenever a consumer goes down, revoke partitions from consumers, and reassign partitions to consumers. So this is the responsibility of coordinator consumer. All these things are the responsibility of the coordinator consumer. So initially what happens, so let's say we have consumer 1, consumer 2, and consumer 3, and let's say C1 is the consumer coordinator consumer. So this C1, what it will do is it will assign topics partition to a corresponding consumer. Let's say it assigned consumer 1 itself to sensor partition 0. It has assigned itself to partition 0, meaning it will be reading the messages from partition 0, and it has assigned partition 1 to consumer 2 and partition 3 to consumer. So so C1 will maintain a list of all the consumers. Consumer 1, consumer 2, and consumer 3. Now if at all a consumer goes down, if you take any distributed application, the system can go down, in which case the task the task reading the messages from broker 2 is no more reading the messages. So your communication has stopped. So in that case, how the things will work now? Who will be consuming the messages from sensor topic partition 1? Who will be consuming the messages from here? Because the consumer is down now. So as we said here, it will trigger rebalancing. Whenever a consumer goes down, it will trigger rebalancing. A rebalancing means as soon as the rebalancing is triggered, all the consumer are stopped from consuming the messages. C1 and C3 will cease consuming the messages from the corresponding topic. So and those topics will be revoked, those partitions will be revoked from the consumer. Revoking means no more consumer 1 will be consuming the messages from sensor. No more consumer 3 will be consuming the messages from sensor topic 2. So that's what happens as a part of rebalancing. Everything will cease consuming the messages, and and the partitions are revoked from the consumers. Then it will reassign the partitions to the consumers. It will the consumer coordinator consumer will reassign it. So in the reassigning, it can assign sensor topic sensor topic to sensor topic 1 to any of the consumer, sorry. So this it will be reassigning. It can reassign it to itself, or it can reassign it to consumer 3. So that's how the continuous flow of data is maintained. So I hope that was clear. How if at all a consumer goes down, how it is maintained. But here the question arises. Let's say consumer 1 has consumed 100 messages. Consumer 2 has consumed 102 messages from its topic. Messages from sensor 0, this from sensor 1, and consumer 3 has consumed 101 messages from sensor 2. Consumer 1 means it has read up to 100 offset. Consumer 1 has read up to 100 offset, 99 offset. Consumer 2 has read 101 offset. Consumer 3 has read 100 offset. A message whose offset is 100. Up till that, the messages are being read. After that, we know that consumer 2 is gone down. The thread on the system on which that thread was running has gone down. Hence, the consumer is down. Now, as a result of that, coordinator consumer will trigger rebalancing. As part of the rebalancing, all the consumer will stop consuming the messages. It will cease consuming the messages. Then those partitions will be revoked, and new partition will be reassigned to the consumers. In which case, sensor consumer one got sensor topic 0 and sensor topic 1. Now where from which offset consumer will consumer 1 will start consuming message for sensor topic 1. So that's the question. From which offset consumer 1 will start consuming. Consumer 1 will start consuming messages from from for sensor topic 1. So obviously it has to start from offset 102. It has to start reading from offset 102. But how does it know? How does consumer 1 know that that's the offset? Because consumer 1 is running in some other system, consumer 2 will be running in some other system, just like this. Consumer 1 is running here, consumer 2 is running here. How does it know from which offset it has to read the message from? And any guess on how consumer 1 will know that it has to read from the 102 offset? No, the offset will not be maintained by the coordinator consumer. Coordinator consumer will not maintain the offset. Each consumer will only maintain its own offset. Consumer 1, which itself is the coordinator consumer, it will maintain its own offset, which was the offset of sensor topic 0. Consumer 2 was maintaining its own offset, that is of sensor topic 1. Consumer 3 similarly was maintaining its own offset, that is of sensor hyphen 2. In this fashion. Each consumer will maintain its own offset. They will not maintain the offset of other consumers. A controller broker also won't help. Controller broker also doesn't maintain any offset. So this actually it will be, this offset will be saved somewhere. This offset will be as Saurav said. So some checkpointing has to be done somewhere. This offset has to be saved. Checkpointing here we are referring to saving somewhere. This offset has to be saved somewhere. So you can save the offset anywhere. Any data store you want, you can save the offset. It is usually called as commit offset. You will be committing this offset. So you can commit the offset to any external storage. Like you can write the offset to MySQL. You can store the offset in Cassandra. You can store the offset in HBase. You can store the offset in Kafka itself. You can store the offset in Zookeeper. But usually Zookeeper is not recommended. Saving here means committing. You will be saving the offset. So there is a configuration called enable auto offset. So there is a configuration, something I don't remember. It's somewhere something like this: auto offset commit dot enable. So this is the configuration which will be on the consumer, and by default its value is true. Auto offset commit enable, by default its value is true, and by default the offset is committed to Kafka. To Kafka, to Kafka as a separate topic. There will be a topic created to commit the offset itself. I mean, it is a system topic. Internally, a system topic, not a user created topic will be there. Just like add logs, sensors are we created topic. Those are all user created topic. For committing offset, by default, a topic will be already created by the system. And to that topic, all the messages, all the offset will be committed. So it will be something like this. And it will also have something like commit interval. So every commit interval, let's say the commit interval is 5 seconds. So every 5 seconds, the offset will be committed to any external storage by default. If it is enabled, you will be committing by to the Kafka itself. I mean, we don't have to write any code here for offset commitment. If you want to use the default behavior, so you don't have to write any code. But if you want to manually commit the offset, then you have to write the code. So in case of default, in case of default, so this is your Kafka. This is your Kafka. Multiple brokers are here. Multiple brokers are here. Now let's say we have application one, some application. Let's say it is a Spark application, and we have one Flink application. We have some one more Spark application. These are all are consuming the messages from sensor topic. So here we have consumer 1, consumer 2, consumer 3. Here we have consumer 1, consumer 2. Here we have consumer 1, consumer 2, consumer 3, consumer 4. Let's say we have in this fashion. And let's say we have sensor 0, sensor 1, sensor 2, and sensor 3. So we have 4 partitions for our sensor topic, and these are our applications, consumer applications. So since it has 3 consumers, so one of the consumer will be consuming messages from 2 topics, 2 partitions, and other will be this fashion. So here, as you can see here, consumer 1 is consuming from 2 partitions. So that's how the consumption works. For in an application, based on how many consumers you have, your partitions will be assigned among those consumers. Now here we have one more application, some Flink streaming application. It has only 2 consumers, so it will be consuming, consumer 1 will be consuming from 2 partitions, consumer 2 also will be consuming from two partitions. So that's how the consumption works. That's how the consumption works. And since here we have four consumers, each consumer will be consuming from a single partition. There will be one-to-one mapping from a consumer to a partition. So I hope you got the idea here. How the consumption happens. How the consumption happens. So here every application will have a unique ID. Every application will have a unique ID. That unique ID will be configured through group. So whenever you write a consumer, here is a question: how is a coordinator consumer is elected in the application? I'm sorry, I don't know that. I still need to check. Probably it works the same way as the controller broker, but not sure. Let me check on that. Let me check on that. How the coordinator consumer election happens? Let me check on that. Probably in a day or two, I will go through that. I never thought of looking into that, but I will look into that. Now we have everywhere you will having a group ID. You have to uniquely assign some ID here. Something usually like Spark streaming application, sensor processing. Some name you will be giving, unique ID. Here also group ID, Flink data processing, some sensor, some streaming, some data extra processing. You can give something. Some unique name should be given. I mean, this is also a mandatory parameter. So on the producer side, you have Bootstrap server, key serializer, value serializer. These are the mandatory configurations on the producer side: key serializer, value serializer, and Bootstrap server. On the consumer side, the 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 mandatory parameters or configurations are Bootstrap server. Similarly, we have key deserializer and value deserializer, and one more is the group ID. It's just some unique name for your application. Unique name for your application. That's the group ID. That those things are these four are the mandatory parameters on the consumer side. The idea of group ID here is now since all the streaming applications are consuming from the same topic. Everybody is reading from the sensor topic. Now they will be committing the offset to Kafka by default. They will be committing offset commit will be done. Everybody will be doing the offset commit. offset commit by default. Now how offset commit is nothing but just we haven't explained the offset commit yet, Rohit. Offset committing is just introduction is nothing but you. So why offset commit is required? Because if at all that's the one I just said. Why offset commit is required? Why offset committing is required? The reason is because let's say the consumer 1 has consumed 100 messages, consumer 2 has consumed 102 messages, consumer 3 has consumed 101 messages. Now after doing all these stuffs, consumer 2 went down. As soon as consumer 2 goes down, consumer 1, which is a coordinator consumer, will trigger rebalancing. As a result of rebalancing, consumer 1 is responsible for now reading the messages from sensor 1 or consuming the messages from sensor 1. Now how does consumer 1 know from which offset it has to start consuming the message? So because nobody will maintain other consumers offset. Each consumer will only maintain its offset till what messages it has read. So for consumer 1 to start reading from 102 message, it has to know that the offset it has to send as 102 to the broker. So it unless you save the offset somewhere, nobody can know from which offset the messages has to be read. So that's the reason we have to commit the offset. So I hope Rohit that was clear. Why offset commit is required. Yeah. Now how offset commit is done? We know why offset commit is required. Now how offset commit is done? Offset commit is done can be done to any of the external storage, including Kafka as well. I mean, MySQL, you can save the offset to Cassandra, HBase, Kafka, Zookeeper, anywhere you can store the offset. But by default, offset is this is the configuration that is used to commit the offset. Auto offset commit enable, and it is by default true, and by default the offset is committed to Kafka itself, committed to a separate topic. By default it is committed to Kafka as a separate topic, and this topic will be already created by the Kafka. It's called as a system topic. And there is commit interval as well, meaning if it is 5 seconds, every 5 seconds the offset will be committed. Not that it will not be committed for every request. First the request, this is request 1, this is request 2, this is request 2. As soon as we get the response for request 1, offset may not be committed. As soon as we receive the response for request 2, the offset may not be committed. Offset will be committed only after the commit interval expires, which could be 5 seconds. And this is how the offset can be committed, and by default it is committed to Kafka itself. So what I'm trying to say here is, so by default this here we know that the Kafka consumer will be there, embedded here. Kafka, I mean, these are the consumers. My mistake. These actually are the consumers which are embedded inside your Kafka, a Spark application. So they will each consumer will commit the offset. Now, how will they commit the offset? How they will commit the offset? So this consumer will say that this consumer, I will just say group ID X. This is group ID Y. This is group ID Z. So it will say Z. This will say for group ID X, group ID X, sensor fun, sensor topic 0, offset is probably 100. This is how it will commit commit the offset. Every 5 seconds, whatever is the latest offset it has read, it will commit it. This will say for group ID X, sensor 0, offset it might have read 101 messages. uh, at 5 seconds, after 5 seconds it will send a commit to the car. Similarly, this will say y as the group ID, because group is y here, and it will say sensor hyphen 0, offset is 100, something. It might have read only 50 messages. Again it will say y sensor partition 0, sorry, partition 1 also it is reading, probably it has read 51 messages. Consumer 2, the way it will say group ID Y, sensor 2, it might have read 52 messages. Sensor 3, it might have read 50 messages. This is how it will commit every commit interval. Similarly, these will also commit these messages. Every 5 seconds, whatever is the latest offset, it will commit. To be more specific here, to be more specific, so if I have a consumer, here which is running in app X, X is the group ID, I will say X is the group ID. So it has sent the request to the broker. First request it has sent, request 1, it will say sensor topic 0th partition and from 0th offset. So for this it got 10 messages. It got 10 messages. So what it will do is it will send the next request now. Request 2. Again it will say sensor partition 0, offset will be 10. So for which it got 20 messages. So it will send the next request, request 3, sensor partition 0, it will say 10 plus 20 30, offset as 30 it will say. This will be the next request saying I want the messages from 30th request. Now at this point of time, 5 seconds is over. Commit interval is over. Now the consumer will commit offset, saying for group ID X, sensor from 0, offset is 30. Offset is 30. Again it will start sending the fourth request. Sensor offset is again, sorry, partition is 0 again, and offset, let's say, uh, for this, let's say we got 10 more messages. For the third request, let's say we got 10 more messages. So it will say offset as 40. Request 5, sensor 0, again it got some, for this request it got 10 more messages. So the message it will say as 50. So as soon as it sends the request, your 5 seconds is over. 5 seconds expired. So again it will update this offset. Now it will, I mean, latest offset will be now, not update will happen. It will be sensor 50 will be the, it will commit the latest offset as 50. So that's how the commit works. That's how the commit works. Offset commit. Now if the consumer, let's say there are other consumers also, and they are also committing their offset. They are also committing their offset. Now if at all the consumer one goes down, rebalancing will happen. Let's say consumer gets to read the messages from sensor 0. Now consumer 2 will go and check what was the latest offset. It will see that the latest offset that was consumed was 50. Now it will start sending the message, sending, it will send the request from 50th offset onwards, from the 50th offset onwards. So that's how the commit offset is useful. Commit offset is useful so that you don't lose some data, you don't read the duplicate data, all those can be maintained here. So that's the use of commit offset. So I hope you got the idea of commit offset here. So every 5 seconds the offset will be whatever is the latest offset that has consumed, it will be committed on the Kafka by default. So I hope you got the idea. Now what happens? This is the default behavior. This is our Kafka. This is the default behavior. This is the default behavior. Every 5 seconds, I mean, the commit interval could be anything. Here we are assuming the commit interval is 5 seconds, meaning every 5 seconds the offset will be committed. Now let's say at 0th second, at 0th second, or we'll start with the first second. The first second, 10 messages are consumed. 10 messages are consumed. Next second, second, again 10 messages are consumed. Third second, again let's say 20 messages are consumed. And so on things are happening. So on things are happening. Let's say at 101 second, 101 second, some thousand messages are consumed. This is our hundredth second. Let's say at 100th second, some thousand messages are consumed. So at 100th second, the commit interval expires. We know that every 5-second commit interval expires. So at 100th second also commit interval will expire. So offset that is committed is commit offset is 1000. This will be the commit offset. The latest commit offset will be 1000. This is for consumer 1. At 101 second, it read some 50 messages. At 101 second, it read 50 messages. So totally it has read 1000, 1050. Now at 102 second, second, some again 50 messages are consumed. So the total messages that is consumed after the latest offset is, after the commit of latest offset is 1100 messages. 1100 messages has been consumed. Now the consumer one goes down. At 100 second, at this second, our consumer went down. Our consumer went down. Now, as we know that rebalancing will be triggered, some other consumer will start consuming the messages from this sensor topic 0. It will check that the last offset commit offset was 1000. Even though even though 100 extra messages has already been consumed, but the commit offset will be seen by the one more consumer as 1000 because that was the last offset that was committed, because before committing it crashed because commit interval was 5 seconds. So what will the consumer 2 will do now? Consumer 2 will send the request. It will send the request that I want the data from sensor topic 0th partition, and it will say 1000 as the offset because that was the last offset. So here 100 messages are reread, are read again. So we are reading duplicate messages here. So we are reading duplicate messages. So I hope you got the idea what is happening here. So when we have a default commit scenario, when we have the default commit scenario, yeah, I will explain it once again. So we have our consumer one. So consumer one send the request first second. It read 10 messages. I mean, it sent a request. This consumer sent the request to the broker. The request was something like this: sensor topic 0th offset from 0th partition and from 0th offset. That was the request it was sent. Because of that request, the broker sent 10 messages. The broker sent 10 messages. So in the in the next second, what will be the request? The first second, this was the request 1 we sent, for which the broker sent 10 messages. In the next second, so the request that will be sent is sensor topic, zeroth partition, offset will be 10, for which let's say it again send 10 messages. For third second, again the request that was sent was third request. It sent sensor topic, zeroth partition, offset is this time it will be 10 10 20. Offset is 20, for which let's say it received uh, uh, 40 messages. So fourth second, let's say these are I'm just giving the assumption of every second we are sending the request. It may not happen in that fashion. Sensor 0. So this time the offset total messages that it has read is 60. So the next offset that it will go as this. And at the fifth second, again you will, let's say for this request it has consumed some again 10 messages. So the next request that you will say is request 5, sensor 0, it will send the offset as 70. So now since 5 second is over, our commit interval expires here. Commit interval is 5 seconds. As soon as 5 seconds is over, so the offset that will be committed is commit offset is 70. This is the commit offset. So on the messages are being read. So I'm just saying that at the 100th second, you are sending some request. Let's say some 100th request itself will assume here. So it will say sensor 0 0, and let's say it has consumed 1000 messages. It has consumed 1000 messages. The offset that it will say as 1000. Now 100th second means that session expiry has happened. So now the commit offset will be whatever it has committed, the offset will be 1000. At 5 seconds the offset was 70. At 5 seconds the offset commit was 70, meaning up till 70 messages it has read. At 100th second offset commit is 1000. Now at 101 second and 102 second. So here it is sending some request, 101 request. Sensor 0 topic, it will for this it might have received some 10 messages. So it will be 100 and 1010. Again for this it might have received 50 messages. It might have received 50 messages. So the next request that will go is request 102. So we have sensor offset 0. So since total is 60, 1060 offset will be going. For this it might be receiving. So before it could receive any messages, our consumer is down now. C1 is down. Consumer C1 is down at 102 second due to some reason. So because of which rebalancing will be triggered. Some other consumer will start consuming the messages from sensor topic. Let's say consumer 2 now has to get the messages from sensor topic. Now it will check that the offset that was committed, as I said, the offset is committed in the Kafka itself. By default, the offset is committed in the Kafka itself. So it will check that the latest offset that is committed is 1000. So here it will send a request. Its first request will be for sensor topic will be sensor topic is sensor 0, sensor topic partition 0, and it will say offset as 1000 because the latest offset that was committed was 1000, because the time interval commit interval did not expire. Before the commit interval could expire, your consumer went down. So it was not able to commit this extra 60 messages. It was not able to commit that the latest offset that was consumed was 1060. It committed only the previous commit will be taken. But these 60 messages are already being consumed. Probably our application has consumed and processed that data also, but it was never committed that these messages were consumed. Hence 60 messages are consumed once again. So I hope this was clear. So I hope this was clear. Here what I'm trying to say here is in default scenario or in default case where committing is automatically done by the consumer itself. We don't have to do anything. In the default case, you will always get duplicate data. You will be consuming duplicate messages. You will be always getting duplicate data. So such scenarios are called as at least once semantics. It is called as at least once semantics. Because at least once is meaning you can get more than once also. You can get more than once. So hence they call it as at least one semantics. So Kafka is by default at least once. Kafka by default supports at least once semantics. So you can always get a whenever all these things are associated whenever whenever something goes down. In normal scenario it will not come. These all things will come into picture only when a consumer goes down, some other consumer takes the responsibility. In fault tolerance scenario context or scenario itself, you will see whether this Kafka is at least one semantics, at most one semantics, or exactly one semantics. So here by default, Kafka by default supports at least one semantics, meaning you will get duplicates if at all a consumer goes down and some other consumer takes care of the reading the data from a particular partition. So I hope it was clear. Rohit, I hope it was clear. So since we get the duplicates, we are reading these messages once again, two times. So hence we say at least once, not just once, at least once. So two times we are reading, hence we call it as at least once semantics. So we can achieve at least once semantics. There are different semantics. At least one semantics, at most once semantics, and exactly once semantics. So these are all the business requirement. Do you want at least one semantics? Do you want at most one semantics? Or whether you want the exactly one semantics? Now at least one semantics, there will be duplicate data, duplicate in fact messages. At most once means once or zero, zero or one. At most one meaning there you might not receive the messages at all. In that case, we can think it as a data loss. At most once means you will receive once or you may not receive at all. If you don't receive at all, it is as good as saying you have lost those messages. So it corresponds to data loss. Now exactly one semantics means no duplicates nor any data loss. The best way to say it, no message loss. So this is a bit tough to achieve. Exactly one semantics is a bit tough to achieve, but this and anyway this is by default. By default, Kafka supports this at least once semantics. So so if at all you want, let's say you are getting the messages from Twitter, so it is okay to get some duplicates or it's okay to lose some messages. So you don't care about much there. Sometimes some business use cases it is okay to get the duplicates or it is okay to lose some messages, Twitter data, GPS locations data. So these are all okay to lose some messages. So you can either go with at least one semantics or at most one semantics. Now sometimes you are doing your credit card transaction. So if a Visa is the company, millions of users will be using the Visa credit card. So they will be swiping here and there on a daily basis, some 2-3 transactions by every user. So you will be getting millions of transactions on a daily basis. So these transactions and if you want to detect fraud, if you want to detect fraud, obviously you cannot afford to lose a single transaction also, because that transaction could have been a fraud transaction. So in such case, you cannot use the default behavior of Kafka. So if you want to achieve such use cases, you cannot go with the default behavior of Kafka. So you have to explicitly commit the offset. So that's where uh, your manual manual commit offset has to be done. This is where the developer writes the code. So for manual offset commitment, the developer has to write the code. So 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 we can choose we can sorry. So you can choose anywhere the messages to be committed. Offset can be committed. So we have to write the code to commit the offset. You can commit it to MySQL, Cassandra, HBase, Kafka, Zookeeper, anywhere you can commit it. Usually this is Zookeeper is not recommended. But earlier they used to commit in the earlier versions of Kafka. I think Kafka 8 up till Kafka 0.8, offset commit was in offset was committed to Zookeeper by default. From Kafka 9 onwards, offset is committed to Kafka itself. So they have removed the dependency on the Zookeeper for only offset management. For doing offset management, the Zookeeper is no more required. But Zookeeper is still being used for other use cases: election of the leader, election of the controller broker, maintaining the membership of the brokers. For all those purposes, Zookeeper is still being used. Offset management was also done, but it has been removed from Kafka 9 onwards. This is how it used to achieve at least one semantics. So then in Kafka 10 something was introduced. I think Kafka streams was introduced. I forgot to say all these things. Kafka 11 recently that is been introduced. This is the latest version of Kafka. Till here it is at least once semantics. Kafka 11 they solved for exactly once semantics. From Kafka 11 you get it for exactly once semantics. So that's how the things they are keep on doing. So achieve you get to achieve exactly one semantics. Where did I- You get to achieve exactly once semantics with Kafka 11 without writing any code, just by doing some configuration changes. It requires some configuration changes on the producer side. It requires configuration changes on the consumer side. So you can achieve the exactly one semantics. But again, it may not be for every they did it for Kafka stream as a consumer. In that case, the Kafka streams was the consumer. Spark streaming, whether it supports, I need to check. But we have to do our own manual commitment of offset. So by doing manual commitment of offset, we can also achieve at least one semantics, at most one semantics, or exactly one semantics. All these things we can achieve by manually doing the offset commit. So for that we have to write the code. We will see that. We will see that. So before seeing that, I think we will see that the whole thing we will see in the next session. But I hope till here the things were clear. How how the offset commitment is being done. Did I keep that? So I hope all these things are clear now. Coordinator consumer, how the rebalancing happens, how the offsets, what are offsets, and how the offset management is. And we haven't we have only seen the default behavior. We did not see how to write the code by ourselves to do the offset management. And I hope we are able to understand all the delivery semantics. So tomorrow we'll see how, I mean, as part of the project, we will see the offset management, how we can ourselves write the offset to some external storage. I will showcase this writing the code to achieve at least once, at most once, or exactly once semantics. So let's wind up the session here and let's continue tomorrow. Thanks everybody. Good night and have a nice day.